Hello and welcome to another Orange Coast College mathematics video. In this video, we're going to learn to solve compound inequalities that use the word and. So things that look like this when we have a linear inequality and another linear inequality. Now the way we solve these is we solve each inequality separately and we look at the solution set for both. Now the solution to the compound inequality is anything that is a solution to this inequality and this inequality, which means we're looking for the intersection of both solution sets. So the goal here is we find the solution set of the first inequality, we find the solution set of the second inequality, and we take the intersection of both. So before we begin, I'm assuming that you're familiar with solving linear inequalities like both of these, and that you understand how to find the intersection of two sets. All right, let's start by solving this compound inequality. So first we add 2 to both sides over here, and we have 3x is larger than -6. We divide both sides by 3, and we arrive at our solution set x is greater than or equal to -2. And now we have to do the same thing on the other side. Now I'm going to subtract 1 from both sides, and at the same time I want to distribute the -2 there to that x minus 4. So what we end up with is -2x plus 8 is greater than 2. We subtract 8 from both sides, and I arrive at -2x is larger than -6. Divide by -2 on both sides. And remember, when you divide by a negative number or multiply by a negative number on both sides, you have to change the direction of the inequality, and we get x is less than 3. So our solution set here, it is x is greater than or equal to -2. So that is -2 to infinity. Over here, it's x is less than 3. So that's -infinity to 3. So the intersection of those two sets is from -2 up to 3. That's every number that they both have in common. Here's our second example, and while the inequalities themselves can be a little bit more work, there's not much to do here that's different. So we start by solving each one separately. So I'm going to start by adding 3 to both sides here. That will leave me with 21 is greater than 7x. I can divide both sides of this inequality by 7, and I arrive at 3 is larger than x. I like to write mine a little the other way, so it's x is less than 3. So the variable's on the left. You don't have to do that, though. And now I solve the other one. So first I have to just distribute this 4 here and this 2 here. So we get 10 plus 4 minus 12x is greater than or equal to 22 minus 4x. And so now we simplify both sides. So I get 14 minus 12x is greater than 22 minus 4x. So I'm going to add 4x to both sides. I want my variable on the left. It doesn't matter, though. And I'm going to subtract 14 from both sides. So let's see. So we will get -8x is greater than or equal to, what do we have here? 8. Okay, and so divide through by -8 on both sides, and don't forget this is going to change the direction of the inequality. We get x is less than or equal to -1. So x is less than or equal to -1, and x is greater than 3. So we're looking for all of the numbers that are less than 3 and less than -1, but that's just everything that's less than -1. So the solution set is from -infinity to -1, because that's all of the numbers that will solve both this and this. Example 3. All right, over here we start by simplifying both sides of the inequality. So we distribute that 7, we get 7x minus 7 plus 2 is less than -5. So I have 7x minus 5 is less than -5. If I add 5 to both sides now, I get 7x is less than 0. Dividing both sides by 7, we get x is less than 0. And so now on the right inequality, we have to simplify this as well. So I get -6 is greater than, I'm going to distribute that 2. So I get 2 times -x over 2. So that's like -1/2 x. So I just get -x here. And then minus 3. Again, simplify the right-hand side. You're going to get 2 minus 3 is -1. So I get -1 minus x. And I'm going to add 1 to both sides. and I get negative 5 is greater than negative x. I'm going to multiply, or you can divide both sides by negative 1. That will change the direction of the inequality. So I get 5 is less than x, or x is greater than 5. And so now we're looking for the solution. We're looking for all real numbers that are less than 0 and greater than or equal to 5. Now, you might wonder, does that number exist? And the answer is no, right? There is no number that's less than 0 and greater than 5. So the solution to this compound inequality is that there is no solution. So you can write no solution, or you can write down the symbol for like the empty set, which looks like this. And here's our final example. So we want to find the solution set to this compound inequality. Negative 1 is less than or equal to 3 minus 2x over 7, which is less than 5. And so really this is a compound inequality. What this compound, when it's written like this is actually the compound inequality. Negative 1 is less than or equal to 3 minus 2x over 7, and 3 minus 2x over 7 is less than 5. But the nice advantage of having it written like this instead of like this is that we can actually solve both of them, the inequalities, simultaneously, more or less. So the first thing I want to do is I want to get rid of this fraction. So what I can do is I multiply all 3 sides of this inequality by 5, or 7, sorry. And that will clear the fraction in the middle. And so what I'm left with here is negative 7 is less than or equal to 3 minus 2x, and 7 over 7 cancels out, and 35. And again, I just have to do the same thing. It's like solving an inequality with 3 sides. As long as I do the same thing to all 3 sides, I'm fine. So I'm going to subtract 3 from each side, or I want to get rid of that 3. So I subtract 3 from each side. That leaves me with negative 10 is less than or equal to negative 2x is less than 32. Okay. And then finally, I'm going to divide each side by negative 2. Now, don't forget, when you divide each side by a negative number, it will change the direction of the inequality. So I will get 5 is greater than or equal to x is greater than negative 16. Or if you wanted to rewrite it with the direction differently, it's x is greater than negative 16, but less than or equal to 5. So as an interval, that would be negative 16 to 5, with the parenthesis on the negative 16, the bracket on the 5. And that's it for compound inequalities involving and. Now, there's a few parts of this that you might find tricky. One, if you're having trouble with the inequalities themselves, right, you have to do, for each problem, you have to correctly do 2 inequalities. If you do one of them wrong, you're going to have a hard time getting the correct answer. So you have to be very careful while doing both inequalities to make sure that they're both correct. And if that's not a problem, then if you're having trouble with the intersection, finding the intersection of the solution sets, maybe go back and review your set theory on intersections. The next video up is going to be doing the same thing, but now with the or instead of and. All right, until next time, have fun.